In this video, we're going to solve systems of three equations and three variables. It says solve the following systems of equations, and it gives us three equations to work with. And they want us to find the ordered triple, x, y, and z, that satisfies this system of equations. I'm going to mark each of these as a different numbered equation. And what I'm going to do is I'm going to combine the first and second equation, and I'm going to cancel a variable. And then I'm going to combine the first and the third equation and cancel the same variable. So I'm using the same equation with two different other equations to cancel out a specific variable. And then you can see where we're going after that is we'll take those two equations we get and then cancel another variable. So I'm going to start by writing down that I'm going to combine 1 and 2 together, and I'm going to cancel, and I'm just going to say cancel x. And then I'm going to take and combine 1 and 3 together, and I'm going to also cancel x. And these have to be the same so that we end up canceling the same variables there. So negative x plus 4y minus z equal to negative 16. And 2x plus 3y minus 4z equals negative 8. And then rewrite that first equation. And we're going to write the third equation this time. So to cancel the x value, I'm going to multiply the top of this equation by 2. And that would be negative 2x plus 8y minus 2z is equal to negative 32. And then I'm going to add these together. Remember to lightly cross this out. I'm going to add these together. That'll be 0, 11y minus 6z equals negative 40. We're going to cancel the x's on this one. I'm going to multiply the top by negative 2 to get them opposite signed. That would be 2x minus 8y plus 2z equals 32. And then I'm going to add them together. That's 0, that's negative 12y, and that would be negative z plus 2z, that's just 1z, and then that's 27. So now we're going to combine these two together, and I'm going to say that we're going to cancel z, because it looks a little easier to cancel. So we're going to write them 11y minus 6z equals negative 40, and negative 12y plus z equals 27. I'm going to multiply the bottom equation by 6. So that's negative 72y plus 6z equals 6 times 27, 162. And then, after that, we're going to take and move this. I'm going to move the top equation down, so it'll be 11y minus 6z equals negative 40. So I'm going to lightly cross that kind of little piece out. So we're going to cross this out and then cross this out, and then we're going to work with these two equations we've got here. Let's add it, and that's going to give you negative, let's see, negative 72 plus 11 would be negative 61y equals, when we add those, we get 122. Now we're going to divide by negative 61 on each side. And we get y equals negative 2. Now we're going to find z by plugging this back in to, I'm going to use the right equation. I could use either one, but I'm going to use the right equation. So that'll be negative 12 times negative 2 plus z equals 27. So it's 24 plus z equals 27. Subtract the 24, and you get z equals 3. Now I'm going to take both of those numbers, plug them into the top equation here, and I should be able to find x. So I get negative x plus 4 times y, which is negative 2, minus the z, which is 3, is equal to negative 16. So I get negative x minus 8 minus 3 is equal to negative 16. So I get negative x minus 11 equal to negative 16. I'm going to add 11 to each side. So that's negative x equals negative 5. And then divide by a negative, and x equals 5. So now I have 5. I can write 5, negative 2, and 3 is the solution to the system.